Hello students, most welcome of you all again in AG Physics channel. You know that our refraction and reflection of light chapter is going on. So today I will discuss with you all some application part of refraction and reflection of light. Clear? Basically I will discuss with you all refraction by glass slab. Means how refraction takes place in the glass slab. Okay, after that we will start our glass prism. Firstly we will discuss here refraction by glass slab. Okay, so before starting glass slab condition, I'm discussing some basic terms related to the refraction of light. One point is there, when light will travel from rare to denser medium, so simply it will bend towards normal. Second point we can include here, when light will travel from denser to rare medium, it will move away from the normal. This bending concept, moving away from the normal concept, comes due to the speed of light only. Okay, means speed of light will decrease, sometimes it will increase. Due to this we are getting here a refraction in the light. Clear? Now I will discuss with you all glass slab. Okay, listen student, we can say this is our glass slab. Okay or not? Okay, so glass slab I discussed already, but one thing I'm telling here again, so we can see glass slab is the denser medium. I told you na, as you know that what is the meaning of rare medium, what is the meaning of denser medium, but we can include here rare and denser. Means you can see here three medium system. One is this medium system first, this is our second medium, or this is our third medium. Again we will get here first medium. So this medium is one, but according to it this medium will be third medium. Clear? So simply you know that light will come, ray will come from the rare medium. Clear? So we can say this is our ray of light. So simply we will draw here normal, because normal will help to separate, making separation between incident light, incident ray and the refracted ray. Clear? So simply we will draw here normal. So this is our normal line. Say yes or no. So you have to follow ray on this normal at a certain angle. This angle is angle of incidence. Here you can say this angle of incidence or I angle. Say yes or no. You know, this is the rare medium, this is the denser medium. Condition is there, when light will travel from rare to denser medium, it will bend towards normal. Means we can say light should travel as same like in straight line, but it will not follow the straight path, it will bend towards normal as same like it. Okay, now again you are getting two medium condition, that is this is the denser medium, this is the rare medium, then you have to draw again here normal. Say yes or no. You can see light will travel from denser to rare, so it should move as same like it, but not, it will not follow this path, it will move away from the normal as same like it. Say yes or no. So simply you can see here two term process, rare to denser and denser to rare. Say yes or no. So in this case, listen student, so we can call this light will be incident light, incident ray, you can say direction of it downside. Clear? Or this will be your refracted, this is the refracted ray, refracted ray of light. Say yes or no. Or then this is the third one means first incident, refracted, or this will be emergent, EMER, emergent ray. Say yes or no. So direction you can see here as same like it. Emergent ray will get only when it passed through two more processes. One is the incident, then refracted, then third one we will get here emergent ray. Clear? So this angle is incident, or this angle also what? Refraction. Means in medium angle formed, that is the refracted angle. Say yes or no. This is our angle of refraction, or this is the vertical opposite. So because this is normal na, this also normal, so we can say both are parallel to each other. So we can say if this angle is R, so this angle will be R. Clear? Or this outer angle will be emergent angle, we can say this angle is E angle. Say yes or no. One thing, listen student, very basic thing I'm telling, angle I and angle E, maximum to maximum time, both are equal. Clear? Both are equal. This is the condition. Means incident angle and emergent angle will be equal to each other. Say yes or no. How we can get minor difference, but we will not include this one. Can be 0.1, 0.2. So this much difference we will get. If incidence angle sometimes, not always, sometimes, if incidence angle can say that is 40 degree, but emergent angle can be 41 degree. Only 1 degree difference we can get here. Clear? Student understood or not? So this is the process in the case of glass slab. Clear? So next thing I'm telling here, this is the glass slab. Okay, student, you are understanding that this is the glass slab, incident ray, refracted ray, or this is your means we can say emergent ray. One thing, listen, if you will increase this emergent ray in forward direction and same this incident ray you will draw in forward direction, what will you see? Both will be parallel to each other. Both will be parallel to each other. You can measure by scale. Practically you can measure. Means always this incident ray, this is the incident ray na. The incident ray or this will be emergent ray. Both will be parallel to each other. So you can see this incident ray little bit shift up downside become emergent ray. Clear? But both rays are in air. This is also in air medium. This is also in the air medium. So we can set both places angle will be same. Means incident angle is equal to the emergent angle. So this distance, this distance name is called lateral displacement. Examiner can ask you what is the difference between, what do you mean by lateral displacement? You also will say the difference between incident ray, the perpendicular distance between incident ray and emergent ray is called lateral displacement. Okay or not? Okay, student. So you have to think always simply incident ray and refracted ray will be as same like it, or refracted ray will be incident of for this one. Incident for this one. So we can say this ray and this ray will be as same like it. But incident ray, when you will increase in forward side, and emergent ray both will be parallel to each other. So the separation we can find out by drawing parallel on both. So we can say this ray will form here. The distance, if the distance is the perpendicular distance, here also the perpendicular distance. Understood or not, student? Understood or not? So this is the lateral displacement. Derivation is not in your syllabus, so I will not tell you the derivation of it, but derivation is too simple and we can understand it. But I'm drawing here perpendicular here na. You students, you also can draw here perpendicular also as same like it. Clear na? So this is our, we can say this is your thickness of the glass slab. Clear? But one thing you can see, you have to put one thing in your mind, that means incident ray and emergent ray both will be parallel to each other. Both will be parallel to each other. But in the case of prism, you will not get as same like it. In different manner you will get. In incident ray and the emergent ray, you will not get there in parallel things, parallel combinations. Say yes or no, student? So you can see here, I discussed with you all two process system. One is rare to denser, then denser to rare system. Rare to denser, then denser to rare system. So I am telling you again, this is your normal. So when we will draw means incident ray at means when incident ray fall on normal at any particular angle, that is angle I, so it will bend towards normal. Here it will move away from the normal. Say yes or no? So second point I'm also going to discuss. I discussed already in the case of refractive index. You can, I will suggest that video in the comment section box, in this description box. You can see that video. Okay, I will suggest your 2-3 days before I share that video with you all. Clear? So simply we can say, if this is your glass slab. Again I'm telling, this is your glass slab. Okay or not? Okay, student? If this is your glass slab, okay, student? So this is your glass slab. Clear? So I'm drawing here normal. So one thing, listen, student. If I will send light along with normal, so we can say I'm sending ray of light in this direction as same like it. Then tell me about the refraction process. Tell me about the refraction process. Listen, one thing, student. Incidence angle is that angle which formed between incident ray and the normal. Don't forget this one. Some students maximum times they took here this incident angle. No, interface and not incident ray. You will take incidence angle between incident ray and the normal. Clear? So same thing we will follow here. If light is coming along with normal, so you can see angle I value will be what? Normal here as same like it. Incident ray also as same like it. Then angle I equal to 0. Angle I equal to 0. Then we know Snell's law, refractive index is equal to what? Sin I divided by sin R. अब angle I equal to how much? 0. So we can say sin 0. So this is sin of angle R. So you can replace. So we can say sin R, because R we have to find out na. The refraction process we have to tell. So in this case we have to find out I value also, R value also. Clear? So sin 0 we can say it is equal to 0, and we will get here 0 by n equal to 0. Clear? So we can say angle R or sin 0 is equal to what? Sin 0 equal to sin 0, so sin to sin cancel out, so we can say angle R equal to 0 degree. So we got here angle R value how much? 0. So angle I also 0, angle R also 0, so both angle will be 0, so light will come along with normal, and yeah, you can say move back, yeah, move forward. Means it will not bend here and there. It will not bend in left hand side, it will not bend in the right hand side, because it is coming along with normal. Because angle incidence equal to 0 and diffracted angle also equal to 0. So you have to put one thing also in your mind: when light will come along with normal, so simply it will not deviate from its path. It will remain at its original path. Clear, student? So this is the basic explanation about the glass slab. Now I will discuss with you all about the glass prism. Glass prism. Okay, students, now I'm going to let us start. First of all, we will try to understand what is the meaning of glass prism. Okay, so one thing I'm telling, it is formed by glass, right? So you can understand here the concept of medium. Means we can say air is the rare medium in comparison of glass. So we can say glass will be denser medium. Identification of both: rare medium, molecule will be very far away to each other, and in the case of denser medium, molecule very close to each other. Clear? So we have already studied the refraction of light through a rectangular glass slab. Okay, in a rectangular glass slab, the emergent light ray are parallel to the incident light ray, because the opposite face of a rectangular glass slab are parallel to another. These things I told you in the case of refraction by the glass slab. We will now discuss the refraction of light through a glass object whose opposite faces are not parallel to one another. Clear? So we can say triangular glass prism is such an object. A rectangular glass prism we can see in the diagram. Clear? So see, student, in the case of glass prism we have three rectangular surface and two triangular surface. Clear? So simply we can say, so three-dimensional geometry I'm not able to draw here, but one thing I'm telling, in the case of a glass prism, it's a triangular shape. Clear? So simply we can draw it normally. So we can say this is the front face of the prism and this is the back face of the prism, as same like it. Say yes or no. So we will join here both side, we will join here this side, we will join here this side. Clear? So you can see in this case we have three rectangular surface. You can see first surface is this one, 1, 2, 3, 4. This is a rectangular surface. Second one is this one, 1, 2, 3 and 4. Our third one, this one downside, bottom surface, 1, 2, 3, 4. Say yes or no. So we can say one face, downside, bottom, second face, or this one, third face. So three face we can say rectangular. Clear? And two triangular surface, one is front side, this one, second is back side surface. This is the triangular surface. This is our 1, this is a 2. So in the case of prism, if you will write a definition of it, so simply we can say it's a triangular form of a glass which has two rectangular surface which are not parallel to each other. So this surface and this surface both are not parallel to each other, both are inclined at some angle. You can see angle. Say yes or no. You can see the angle. Clear now? And the second thing we can say, second are both two triangle surface also are included in this case. Three rectangular surface and two triangular surface we are using here. Say yes or no. So opposite faces are not means parallel to each other. They are inclined at some angle. You can see the angle, this is given here, and angle also given here. Clear? If we will try to see in 2 dimension, so in 2 dimension simply we can draw this one as same like it, front side. Clear? So we are using here equilateral prism, so its all angle will remain same. So we can see this is A, this is B, or this is C. Say yes or no, student. So we can say in simple case, in the case of a glass prism, so we can use its 3 sides, A, B and C. These are the refracting surface. You can see air is here, air is here, air is here. So this inside it, glass is present, totally filled by glass. So we can say this surface will be denser surface. Means inside it, whole surface will be denser surface. Say yes or no. Again I am telling that you can see rectangular surface. 1, 2, 3, 4. This is the rectangular. Down bottom surface, and this side surface. Say yes or no. And front side triangular and back side also triangular. Say yes or no, student. This is a basic explanation. Yeah, simple explanation about the glass prism. Okay or not? Okay, student. Condition for it also will remain same. Means same thing. When light will travel from rare to denser medium, it will bend towards normal. Denser to rare, it will move away from the normal. Speed also will give concept in it. That means due to speed decreasing or increasing, we get by it that refraction concept. Clear? But one thing I'm telling, one basic and important thing, that in this case, incident ray or emergent ray will not parallel to each other. So now we are going to discuss here new topic. Let us start, that is the refraction of light through a glass prism. Next topic is what? I'm telling student, listen carefully. This is our next topic, refraction of light through a glass prism. How we will see refraction by the glass prism. So first of all, we will draw here our diagram of glass prism. So little bit big diagram we will draw here. This is the big diagram. Say yes or no, student. Clear? Any doubt to any student? Then I'm telling some basic thing in this case. Listen, this is our prism. One thing, student, if I'm taking light, means light is coming from this surface. We can this A, B and C. If light is coming from AB side, so in this case, what will you see? This is your rare medium, this is your denser medium. This is your rare medium, this is your denser medium. Listen, so this is the interface line which will give a separation between rare medium and denser medium. What will you do for making separation between incident ray and refracted ray? You will draw here normal. This is your normal. Clear? If light will come along with normal, so I told you that you will not get any refraction in the light. When light will travel along with normal, it will move straight. You will not see any bending, anything like that. Clear? So for getting refraction in the case of prism, what will we do? We have to fall light at a certain angle. We have to take here angle less than 90 degree, acute angle less than 90 degree. Clear? So on that time we will get refraction of light. So these things we will draw here in this our given glass prism. So we can say this is our A point, this is our B point, or this is our C point. Clear? So we can say this is your interface line which will separate between two medium, give separation between rare and denser medium. Then I'm drawing here normal. So this is our normal. Normal will make angle with this interface, that is 90 degree. Say yes or no, student. This is making angle with it 90 degree. So I'm taking light at a certain angle, some angle. So we can say this is your incident light, incident ray. Or this angle will be what? Normal and incident ray. In between angle formed, that is the incidence angle. Say yes or no, student. Say yes or no, student. So this is the basic thing. One thing, light should travel as same like it. But light is traveling from rare to denser medium. It will bend towards normal. Say yes or no, student. It will bend towards normal. You can see direction of that is the incident ray and the refracted ray. So this angle will be what? Angle of refraction. Angle of refraction. Again, you can see up there situation before it, that rare medium, denser medium, rare medium, denser medium. Now, first concept we have completed. Now we are coming on the second one. Now we have, this is the denser medium. Now light is ready to move out from this denser medium to rare medium. Say yes or no. So we can say again we are getting this interface line. So we will draw normal on this interface line. This is our normal. So this also making again 90-degree angle with the interface. Say yes or no. Listen student, light should travel as same like it, but it's not. It will simply denser to rare, because this medium is our denser medium. This our rarer medium. This also our rarer medium. Now light is traveling from denser to rare. It will move away from the normal. Away from the normal. Light should travel as same like it, but it will move away from the normal, from its original path. Say yes or no. So we can say this is our next part of the light. So this angle we can say refracted angle, or third case, this angle is the emergent angle. Emergent angle. You can see student, you can see this our incident light. This is our emergent light. Both are not parallel to each other. I told you in the glass slab, incident light and the emergent light both will be parallel to each other. But in this case, we will not get the parallel to each other. Ray of light will not parallel to each other. Say yes or no student. So in this case, you can see this is your emergent angle, this is your refracted angle, this is your incidence angle. Say yes or no. Now you can see, light should travel as same like it. Okay or not okay? But it shift here. It shift now means we can say light is moving, passing through this prism and coming from this side now, coming on this path now. So we can say that this is the path traveled by the light. Clear? If we will draw this one back side as same like it. Listen student. So you can see incident light shift in this direction. So this shifting is called angle of deviation. This del symbol. This is called what? Angle of deviation. This is called angle of deviation. This is called angle of emergent, angle of refraction. But in same medium, we will get same angle. Later I will tell you why we can say this angle also R. Both angle will remain same. Why we are taking both angle remain same. Clear now? So both, this is 90-degree angle. This 90. Later I will tell you. But all those things which we have to confirm here, and explaining all these things only. Incident ray of light, refraction, emergent ray of light, increase emergent ray of light backside, increase incident ray of light forward side. So in between that angle we are getting, that this angle is called angle of deviation. Means we can say angle formed between incident ray and emergent ray is called angle of deviation, denoted by del D. Say yes or no. So this is the basic explanation about the prism. Don't forget this one. Means examiner can ask from you that what do you mean by angle of deviation. So you will say at that angle incident ray shift and become emergent. This angle shifting is called angle of deviation. You can say angle formed between incident ray and emergent ray is called angle of deviation. Some basic trick for it I am telling to you. Listen carefully. Okay students, so this is the angle of deviation. Clear? So one relation I am telling to you all, derivation of it is not in your syllabus. So listen student, we can say this is angle A. Here you can say angle of prism. I am telling to you all on this side of prism, we can say in equilateral form. All angle will remain same. But in all cases it will not. But here I am telling this equilateral prism. So this angle also same, A, B and C. So all angle will remain same. A equal to B equal to C. Clear? If so this angle is called angle of prism. Angle of prism. In 12th class you will understand that how you will find out angle of prism. Clear? So simply we can say angle A, B and C. This is a practical work. So all three angles are same here. Clear? So these angles name we can say these are the angle of prism. What? Angle of prism. So we have one relation. Incidence angle plus emergent angle is equal to angle of prism plus angle of deviation. Say yes or no. So we can say just sum of incidence angle and emergent angle, both sum equal to the angle of prism and angle of deviation. If this angle will be more, according to it this deviated angle will increase or decrease. Later I will tell you on which factors this prism angle and things refractive index of glass prism depends. Clear? Later I will tell you next video. Clear? So we got this relation, angle of incidence plus angle of emergent equal to angle of prism plus angle of deviation. Say yes or no. If someone will ask you find out angle of deviation, so we can say if angle of if angle of incidence we can say 30 degree, of angle of emergent is equal to 31 degree, both are maximum to maximum time can be equal. If this is 30, this is 30 in each cases, but in rare cases we will get some angle, some shifting in the light. Clear? So we can say angle of it's that is 31 degree, or angle of we can say that is emergent, that is 32 degree, and the angle of prism we can say that is 60 degree. Now this is the, we can say that is 30 degree. 60 degree. Then find out angle of deviation. How will you find? Put all value here now. So simply we can solve. How we will solve this one? 30 degree plus 32 degree is equal to 60 degree plus angle of deviation. So if after solving we will get 2 degree angle of deviation. So we will get this angle, that is 2 degree. Say yes or no, student. So this is the basic explanation regarding your refraction of the refraction of light through a glass prism. Clear? In next video I will discuss how white light convert into 7 color, wavelength, frequency, Vibgyor, rainbow concept. I will discuss all these things in the next video. So all students listen carefully and see this video, like, subscribe and share. Clear? If you will get any kind of, we can say, doubts, you can write in the comment section box, or you can send me SMS personally. Okay student, God bless you all.